for this video, we're going to present the Anitu, a machine learning based device equipped with sound recognition and notification system for forest conservation. You might have heard the term Anitu one way or the other, as it is commonly known in the Philippine history as the human-like figures that our ancestor or the Ninunu used to offer their prayers to. The Anitu are placed into sacred places such as shrines, their villages, and even the forest. They are offering their prayers to the Anitu for things such as bountiful harvest, protecting their homes, and even winning wars. Well, clearly this Anitu won't be help them winning war, but can definitely help them in protecting our home, the Philippine forest. Now let's talk about how this presentation will go. First, we have the device. In the introduction, we're going to discuss the problems that leads into the development of the Anitu and also its objective. In the specification, we will show the hardware and software components of the device as well as the system architecture wherein we will discuss the process and the relationship of the different components. Next is the functionality. In here, we're going to discuss the behavior of the individual component as well as the functionality of it. Third is the result. We will show the web page of the Anitu wherein we will be able to access the result of the device. Lastly, the authors. So let's talk about the introduction. There is there has been an increased report on illegal activities in the forest of the Philippines, and the authorities are having hard time in monitoring, recording, and even tracking down the different groups that are performing these illegal activities. NITO will help them identify the illegal activities through sound recognition, and it is also equipped with notification system. Therefore, they will be notified when there is a illegal activity that is occurring in the forest. Now let's talk about the specific problem. Although the technology is readily available, even the device, but locally we don't have this kind of device, and the cost is too much expensive. That's why some may not have thinking of using this kind of device. So the objective of this device is to aid the authorities to crack down illegal activities in the forest using unmanned device through sound recognition, and also to reduce the risk of the forest rangers in patrolling the forest. There are several cases wherein the forest ranger lost their life while performing their duties. So this device will help them in monitoring the condition of the forest of the Philippines. Let's talk about the hardware components. We have Raspberry Pi 4 Model B, sound sensor module KY-038. We have the GSM module and also the Arduino Uno. So we have the Raspberry Pi and the Arduino Uno as our microprocessor, and this will control the other components. We also have the sound sensor. This component will be used to gather the sound input, and also the GSM module that will be used for the notification system. For the software components, we have the Vue.js for the web page front end, also the structured query language or SQL for the database, the Visual Studio Code, and the Arduino IDE for the source code of the microprocessor. Next, we have the system architecture. As you can see in the figure, we have the sound sensor, obviously, that will gather the sound input from the environment. and is connected to the microprocessors. So the microprocessor will use a signal processing technique, which is the fast Fourier transform, to process the data. Also, we have a SIM module and the data classifier, which is the artificial neural network as well as its dataset. But for this presentation, we will not show the data classifier in this video, as well as the SIM module. The next question is, how does it work? How does Anitu really works? So before we proceed, the function of the device itself, let's talk about first the sound sensor. So the sound sensor is defined as a module that detects sound waves through its intensity and converting it to electrical signals. So those sound waves are processed by our microphone. So the sound wave will be converted into electrical signals, and we have the potentiometer to adjust the sensitivity of it. Sound wave is equal to the resistance that is generated after the conversion. Meaning, if there is soft sound, the resistance is higher. If the sound is loud, the resistance is low. So let's talk about the signal processing. The signal processing or the fast Fourier transform is a mathematical method for transforming a function of time into a function of frequency. Sometimes it is described as transforming from the time domain to the frequency domain. It is very useful for time dependent phenomena. Aside from that, the fast Fourier transform can also be used as a signal filter. Let's say, for example, you want to filter or you want to reduce the noise of a given um, sound sample or even image. You can use the fast Fourier transform to reduce the noise of the background. Now, let's go back to the question. How does Anitu works? So as you can see here in our system architecture, sound sensor will gather the input and the FFT will be used to convert the time domain to the frequency domain and to filter the sound input and retain its highest peak frequency. So from the sample, it will then be displayed to the web page of the Anitu that will be shown later on. We have here the web page or the web application of the Anitu. As you can see here, we have the introduction and how to use the web app. Is the result. So as you can see here, using the FFT or the fast Fourier transform to identify the max peak of the sound sensor, we have the first value samples and also we have the converted um, time domain to frequency domain, the red line in our chart. So here we also show the general problem, general objective, and also the beneficiaries of the device. Lastly, we have the authors. So we have uh, Sir John Roy Galvez and Alkin Cesar. So Sir John Roy will discuss the actual video presentation of the functionality of the Anitu, as well as the physical components in the next video. Thank you for watching this video, and that's it.